Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Hybrid Optimization of FOPID Controller and MPPT Technique for Enhancing Control in Solar PV Systems. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the applications that we have designed in the domain of electrical vehicles solar PV systems. So in this we are designing the MPPT maximum power system. So by using the Simulink technology in the MATLAB. So before moving to the video, let's talk about that what we will cover into it. In this video, we will initially talk about the application areas in which the developed system can be used. Then we will talk about whatever the code we have designed, how to execute them, what are the software requirements for it. Along with that, we will discuss out what are the current systems, what exactly they were doing, and the problem identified in them by the proposed system, and what we have developed. Finally, the experimental outcomes and findings will be shown. So let's talk about the application areas. So as the system is designed particularly for the MPPT systems, so MPPT is basically used in the MPPT are used as a controllers for the solar PV systems. So they are specifically designed for the solar energy managements. Secondly, currently electrical vehicles where the batteries are to be charged and we need to charge them at the faster rate. So there the MPPT is playing an important role. So if we are talking about the MPPT solar charge controller, so they are basically the module that is used to charge the batteries by the solar. So that solar batteries can be used in many of the areas, like and currently electrical vehicles are one of the example. Other than that, the grid based PV systems where from the solar panels the power is getted and sent to the multiple sections, like either it can be home, it can be utility grids, or electrical vehicles, or any of the equipment that need to be operated on the solar panels. So these also comes under the grid connected PV systems. Finally, the renewable energy resources where the solar is one of the renewable energy that is used to generate the power and can be utilized further by extracting the maximum power from it to charge the batteries at the user end. So these are the application areas that we have designed. Now let's talk about the code. So we will give you the folder. This is the folder name code, under which we have placed all the files that need to be executed. The whole code is designed in the MATLAB, so we must have the MATLAB software with us. The MATLAB version that we are using is 2019A. So in order to run the current models you need MATLAB 2019. If you want to run it in the earlier version or something, you need the MATLAB 2019 and you can export them to the earlier version. So the requirement for running the current models are 2019. Even you can also run it in 2018. So these are the two models that are required to run the code. So in order to run the code, you just need to go to the folder where all the models has been and the code has been placed. So just copy the path, go to the MATLAB and paste the path. When you will paste path and press enter, you will see all the files those were there in the folder are available in the current folder now. So the files that you need to execute are: one is main proposed, another one is comparison code, third one is AC to DC bus system, right? So these two files are only to analyze the outcomes in a collaborative way at a single place. So the main file is the main proposed code. Here we have developed the whole system and the Simulink models has been designed. So the models that we have designed are of different scenarios. The paper that we are referring, they are generally working on the utility grid only, but we have also analyzed with the resistive load, with the parallel resistive load, with the series resistive load, and also with the base papers model, that is PID model, right? So this is the main model that we have designed. So in order to open these models, you just need to click on the model SLX, not SLXC, it is SLX, because SLXC is the C file generated during the simulation. So the MATLAB Simulink, when you will open, you can see the whole model that we have designed from the reference is here, where we have developed the whole system, but you need not to run it individually, because in the traditional ways we are just going to design the model and we are clicking here to run it, but we are doing it through the code, because we need to identify the optimum outcomes. So to run the code, you just need to give the model name. As you can see here, we have given the model name that we need to run. For example, I'm giving this the proposed one, that is utility grid. OPID means optimized PID MPPT for the utility grid. Similarly, PID is the normal PID system which was existing. So when I'm running this, it will execute this model by itself. The sim command is to simulate the Simulink model that we have designed, but make sure this Simulink model should be there in the folder, then only it will be run. So this is the time duration, that for how much duration you want to execute, because as you can see, when I was opening the model, this one, so there was the time duration written over the method. So in order to run, we just give the time here for the simulation time. This is a stop time of the simulation. So if you are not running it manually, if you are running it through the code, you can give here the details. So I'm running it for half of the second, right? So what we have done, in order to run this, I just need to click on the run button. As I'm running, you can see it start processing. In the meantime it is running, so you can see the iterations has been started. So it will, in the meantime it is running, let's talk about the current system. Many of the people are working on the MPPT systems. The initial stage of the MPPT systems were proposing the P and O method and many basic methods. One of the technology that was used with the MPPT controller was using the PI controller, PID controllers, PD controllers. So the combination of PID, proportional integral, and derivative controllers were used along with the MPPT in order to run the system. So what they have done in this reference article, they have proposed an MPPT controller for the grid connected solar photovoltaic system, in which they have used the PID as a controller, PI based model. Here you can see they have used the PI based model. Then WOA-ALO optimization algorithm has been implemented in order to get the optimum factors for the PI, that is the value of KP and KI, because might be you are aware about the working of the PID controllers, because they are working on the uh, uh, value of the constant of KP, KI, and KD for the whole PID. If it is PI, then it is only KP and KI, and so on. So they were using three of the method, that is PI, and FOPI gain parameters using WOA. So the whole model has been implemented. So this, they gave the irradiance and the temperature. Irradiance is basically the light over the panel of the 400 kilowatt, and then MPPT controller is there. Then they use the PID controller, to which the whole utility grid is connected. So this is the model that they have used. Then they have given the simulated outcomes, where they were discussing about the current MPPT techniques like P and O, INC. So these are the existing methods. So this is PID based controller collaborated with the MPPT in order to get the higher. So this is fractional order PID, and they have used the WOA-ALO optimization algorithm in order to extract the value of KP, KI, and KD. So after that, they have see the outcomes in the two different scenarios, that irradiance and temperature as a static value, then variation in the irradiance and the temperature value. So these are the two cases that they have analyzed. Finally the outputs has been given, and how much overshoot, how much settling time, what is the rising time, they have extracted that and shown in the comparison section. So the problem that we have identified is, one of the thing is the method they are using for the fractional PI fractional order PI and the PID models using the WA, that is the traditional methods, and there are certain restrictions with the PI based method. One of the recent technology in the domain of the systems is like FOPID. So they were using fractional order PI, so we are proposing them to use fractional order overall PID, because all the three factors are, it is reviewed from the literature that the PID controllers are beneficial in many of the areas in comparison to only PI or only IA or that. So that's why we are inspiring our proposed method to shift to FOPI to FOPID controllers. Secondly, we are replacing the whale optimization algorithm by collaborating it with the another algorithm, that is, you can see the two of the method we are using. One is whale optimization algorithm, second is ant lion optimization, which is the recent algorithm given. So there were certain issues with the values extracted with the whale optimization algorithm, that as the highest iteration they got stuck at the local optima. So in order to handle those issues, ant lion optimization is shown effective, and that's why we are proposing a hybrid model of WOA and ant lion optimization as a name of HWOA-LOA. So this is the proposed method that we are given. So what exactly we are doing in every of the iteration, initially what we have given, you can see here we have taken the parameters for the WOA-ALO algorithm, which is the hybrid WOA and ALO method, and under this we are evaluating the objective function, which is basically running the model that we have already designed. So the scenarios that we have designed are like, initially we are analyzing the PID controller based MPPT system with the resistive load, because we have also conducted the analytical study, but the main motive is to work with the MPPT model of the FOPID and hybrid optimization algorithm with the utility grid. So this was for the PID based MPPT load. So here you can see only PID controller has been used, whereas in the OPIDs all variants are the proposed methods. So you can see, if I am doing the comparison with the resistive load, then it is OPID, where you can see the O is the optimized. So here with the MPPT controller we have applied the FOPID model, so to which the KP, KI and KD is to be fed, which is extracted from the hybrid optimization algorithm, and the load that is attached to it is the resistive load. So the variation among the models of the optimized PID are like, in the resistive load we are using the resistance as a load, in the utility grid we replace the output with the utility grid, because the base paper was working on the utility grid, so that's why we are using this one. So in order to compare our proposed methodology, in rest of the two scenarios where the parallel model and the serial model is like, we are applying two different models in order to get the maximum. Here you can see MPPT with the different models. So this is just for the analysis purpose. Series, parallel, resistive load, these are for the analysis purpose. PID based is the existing method, and the proposed final which we are comparing with the base paper is OPID MPPT utility grid, because utility grid is implemented by the base paper. So here you can see they have used the utility grid. So we are using the same configuration, and in order to run this we just need to select this file and rerunning it. Make sure the changes that you need to made while running for any specific model is, you need to give the name here as a model name, only in the name, not here, because this is for the different scenarios, because the values extracted out from the model are in the different way. So only you need to change the name variable with the model name, right? Second, you need to change under the FOBJ file. So FOBJ file, you just need to change the name file. You need not to change here the comparison, because only this is to extract the simulated outcomes, right? So because the model designed for the utility grid is getting the results in a structure way, here it is getting in the database way, so only the way for extracting the information is different. That's why this comparison, string comparison for the name is being applied here. But you just need to make the change in name variable. Here you need to mention the Simulink model name without extension, and similarly in the main proposed file. So you can see it start running and executing. So it will run for number of iterations and give you the output in terms of the parameters that we have extracted. We have extracted the results in the terms of the tabular form as well as in the graphical form for the settling time, rise time, overshoot and peak time, because these are the factors those were calculated by the base paper themselves. So the iteration that we have given at the initial stage is 10 in count. So as per the model and the things, it will start processing, and further after the processing it will gives us the output of the convergence curve initially. That what was the convergence is basically the variation of the fitness. So here you can see it is 3.4775. In the second iteration we were giving it as 3.4707. So it is working. So let's wait for the simulation to get completed. 4 of the iterations has been done. In every of the iteration it is generating a set of kp, ki and kd value, sending it to the model, simulate that model with that value. On that behalf, getting the parameters of values and the time and calculating the things of the convergence. So the fitness is basically calculating the trapezoidal variation of the error among these synchronous. So this is the model that is basically used by most of the researchers in order to evaluate the Simulink model of the MPPT. So the main advantages of the proposed method is like a hybrid optimization algorithm is proposed. Secondly, we are analyzing the different models, not only restricted to the base models only. We are also implementing the PID in order to show the things, and it is having two different scenarios where when I'm gonna show after the simulation that if one they have done with the static irritance and temperature, in second scenario they have done with the variation in the temperature and the irritance. So let the simulation get completed. So you can see it dropped to 3.4706. The variation will be minor, but the impact will be more on the outcomes. So the simulation is reached to iteration number 9. Let's wait for the last iteration to get completed. Then whatever the results we extracted out, we simulated it for the same model again here. So after the last iteration, the results will be presented. 10 of the iterations has been completed. You can see this is the convergence curve that we have achieved after the simulation of the 10 iterations with the model. And then on that we have whatever the simulation will be, the final kpkid values were with us. So you can see those values here in the workspace. So the settling time, rise time, overshoot and peak time, you can see the values here as well as in the graphical form, and the kp, ki, kd value extracted from the simulation is here. So you can keep it with you and can run the system. So what we have done, we have run it for two different scenarios. One is when the model is at the fixed irritance and temperature. So here you can see there are the values. Here the irritance is fixed, temperature is fixed. So this button is connected with the fixed one. So if you want to change for the variable, then you just need to click over here. This button will get connected to this. Again you can connect to this, because here we have generated a signal where the variation of the irritance and the variation of the temperature has been set like this. You can change it accordingly as per your requirement in order to show, but right now you just need to switch this button only, and then you just need to control S save and rerun the code again. So it will start executing for the variable irritance and variable temperature. So this is the change that you need to make for the analysis purpose. So I'm just going to save it. If I'm going to save it, you can see this is saved. After saving, you just need to close it. And now when I will run this, it will run for the variable irridance and variable temperature, right? So you can see if I'm opening it again, it will be connected to the variable model. That is the only change that you need to make. See, so this is what we have developed for the proposed system. In the comparison section, we have saved both the results and did comparison. So you can see we do have the results with us, where we are checking the different parameters from the scopes applied in the Simulink. So these are the graphs with us. So this was the fitness, this was the temperature variation, this was the irridance variation variable, right? So the factors that we got for the variable, one was settling time, rest time, short term, and peak time. So this was the power current curves, voltage curve. This was the case one when temperature was static, irridance was static, then the power extracted was this, current was this, voltage was this. So we did the analysis. Values of kp, ki, kds extracted for both the scenarios has been shown in the lower one. So further modifications are still possible into this. For those information, the industrial people or the research people can contact us directly and can get the information. Thank you. Thanks for watching.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.